How FTIR works in chemical testing of packaging materials. Sample preparation to analyze a packaging material using FTIR. A small sample of the material is typically collected. The sample is often ground into a fine powder or placed directly on an IR transparent window, e.g., potassium bromide or diamond crystal, to obtain a thin, uniform layer. IR source. An infrared light source generates a beam of infrared radiation containing a broad range of wavelengths. Beam splitter. The infrared beam is directed toward a beam splitter, which divides it into two separate beams, the reference beam and the sample beam. Sample beam interaction. The sample beam passes through the packaging material sample. As it does so, specific wavelengths of infrared light are absorbed by the chemical compounds in the material. This absorption is due to the vibrations of the chemical bonds in the molecules. Detector. After passing through the sample beam reaches a detector. The detector measures the intensity of the transmitted light at each wavelength. Interferometer and Fourier transform. The reference beam is also directed to a detector. The data from both detectors are then subjected to Fourier transformation, which converts the data from the time domain to the frequency domain. This process generates an infrared spectrum that represents the absorbance at different wavelengths. Spectrum analysis. The resulting spectrum is a plot of absorbance, intensity of absorption, against wave number, reciprocal of wavelength. The peaks in the spectrum correspond to specific vibrational frequencies associated with the functional groups in the packaging material's chemical compounds. Identification. The FTIR spectrometer is equipped with a database of known spectra for various compounds. By comparing the spectrum of the packaging material with the database, it's possible to identify the chemical components present in the material.